Moving on to this chapter about how to attack modern wireless networks, we will discuss several things: the web protocol, WPA, WPA2 and WPA3, WPS, and we will discuss as well different tools. Several standards actually exist to allow the interaction between different Wi-Fi devices or wireless enabled devices. The most famous standard is the IEEE 802.11 with its various specifications like the A, B, G, and M. Actually, this standard doesn't specify anything related to security. From here, researchers have to come up with extensions and develop extensions in order to allow the establishment of certain security mechanisms. And actually, these extensions are called WEP, WPA, WPA2, and recently WPA3 has been approved since the beginning of 2018. Security in a network where no physical security exists is really a big issue, and you are exposed to different kind of attacks such as man-in-the-middle attack. Someone can capture your session and redirect you to somewhere else. So it's really important to know about wireless security. A quick comparison between WEP WPA and WPA2. As you can see the names, WEP was introduced in the 90s, while WPA2 in 2004 and then WPA 2005. The cipher is RC4 for WEP and WPA, and it's the enhanced AES for WPA2. So as you can see, WPA2 is currently the most secure security extension. The key size varies from 40 bits in WEP to 128 bits in WPA and WPA2, and the key is static in WEP, so for that it's much susceptible to attacks, while the encryption key changes uniquely in WPA and WPA2. WPS, when we say WPS, it's actually Wi-Fi protected setup. So you can see here on the screen some routers are enabled with this WPS hardware button, and you can as well enable it in some of the routers from the setup itself, from the application itself. If you can go here, this is my router here. If you can go to wireless, the WPS, you can click on it to disable WPS and remove it to enable it. What does this button actually do? Well, this button enables you to access your router in a fast way, so you don't have to go to the extensions WEP, WPA and WPA2. Actually, if you have WPS enabled, it will not work on the WEP extension enabled routers. So once WEP is enabled, WPS is disabled by default. So it actually works on WPA, mostly WPA2 routers. So it's about WPS, it has 8-digit pins, and it allows you to connect in a fast way to your router. So again, this is a weakness here. If you were able to crack the WPS pin, you can have access to the routers regardless of the password there or the common phrase used. So even if you change the common phrase on WPA, you can still run some applications in Kali that we will see later on in the chapter, that it can recover the password in a means of seconds, not even minutes. So this is again an important thing to know about wireless router. The tools that we'll be using for the attacks are listed here. So actually any of these tools can perform WPA, WPA2 web and WPS attacks. For the sake of exposing you to different tools, I'll be using a different tool for each kind of attack. So for the WPA2 attack, we will use these applications: Airmon, AirDump and AirReplay. So Airmon actually, it puts the wireless card, your wireless card, into monitoring mode. So it will monitor what's going on around you. The AirDump will actually save the traffic that's going on around you to a PCAP file. And the AirReplay will enable you to inject some packets into this traffic. We will see this into details. For the web attack, we will be using a tool called Fern Wi-Fi. It's a simple tool where it can crack and recover the web keys. So we'll do this into details as well. And as for the WPS hacking, we will use an application called Reaver. Doing some wireless attacks, especially that we're using the virtual Kali image on VMware. So I faced some issues actually using the virtual machine, because by default the virtual machine Kali doesn't have access to my built-in network card. As you can see here, there is no connectivity to the wireless network. So I had to get an external Wi-Fi, USB Wi-Fi adapter and connect it. And you can actually connect it as well from this menu here. It's a TP-Link wireless USB adapter. Just press connect and you will be able to have a Wi-Fi connection here. So after plugging the USB wireless card, you should be able to see the connection from here, or you go to the terminal and issue the command airmon-ng and you'll be able to see the interface here. Actually, I've removed the card now, but what I've done is that because I've faced issues using the external wireless card, I've created a live Kali bootable USB. From there, you can actually boot your laptop from this USB disk and have access directly to the internal wireless card without going through the hassle of having an external wireless card, etc., because it was giving some errors. And it's easy to do that actually. You just go to the Internet Explorer or Chrome here and go to the Kali download page and just go there and download the relevant image that you have, and then go to SourceForge and download this application Win32 Disk Imager. Download this application here and open it from the desktop. It's a very simple application. You just select the image that you've downloaded here and then select the USB drive and then press write. It will create a bootable USB disk with Kali image on. Make sure to change the sequence of boot on your laptop, and here we go, you can boot directly from Kali. It's important as well to know before going ahead with the actual examples here that Wi-Fi uses a 4-way handshake as opposed to the trivial 3-way handshake we've seen earlier. Going into the details of how this handshake is established is beyond this course, but it's important to know this as a prerequisite. There's a 4-way handshake being established or being negotiated before the connection is established. Now we'll see how to crack a WEP network, and for this purpose I'll be using an application called Fern. You can access it under the wireless attacks menu, and then where is Fern? This is Fern Wi-Fi. Web attacks are really very simple and easy. You just need to press a button and the application will do the rest. So on this interface, just select your wireless LAN network here and you press this button to scan for access points. It now detected 1 access point with web enabled and 30 access points using the WPA. So now we're going to press on this button and see that the access point here name is MAJO, and you just select this access point and press on Wi-Fi attack. So that's it, and the application will actually do the rest. And if you see this progress bar here, it's collecting IVs, and then IV actually it's 24-bit field sent and the clear text portion of a message over WE. So, and this is a 24-bit text. It is used to initialize the key stream generated by the RC4 algorithm. You don't have to worry about that. It's just like collecting these IVs, and after it have collected around more than 10,000 IVs, it will try to crack into the password, and you'll get the password shown below.